Okay, in this video, we're going to talk about set screws. So, in the previous videos where we talked about motors and shaft and how to hold on to the motor, some object on the motor to the shaft, especially the shafts with the flats on it, the D profile ones. So, most common application for set screws is you could think of it more generally as something to hold another object together. So it's not just limited to motors, even though that's one of the common applications. So, one thing that if you do a lot of stuff with motors, you'll notice that when you do like a cut point set screw that looks like this here, one issue with this is that it leaves a little bit mark on the shaft. So then sometimes when you're trying to take things apart, you could damage it. It'll leave like a little when that part goes in, the parts, the metal around it might elevate a little bit, and then when you try to remove things, it actually starts getting stuck. So then there's like different things like non-marring. Um, Sometimes you might have a tip that you want to have extended, so you have like extended one. There's also like a high hold cone point set screw. This is like a sharper point contact, so there's going to be more force. You have some easy adjust ball point set screws. So there's a lot of different types. You have like swivel tips, you have spring plungers. So pretty much any time you need some screw to hold on to something, um, you could use a set screw. Like maybe you just want something that you don't want to slip, or maybe something to temporarily hold a location. There's a lot of various applications. Okay, so we'll take a look at the standard one here. You can see that there's a lot of different thread sizes. So thread sizes, all the screws that we talked about in our previous videos, the same rules will apply here. And then um, you could just go ahead and take a look at it. The materials will depend on your application. If you need like corrosion resistance, usually the black ones are pretty nice. But right now, for the sake of just seeing how it works, we're just gonna choose one. So I'll choose a 632. I don't want it to be too tiny. So I'm gonna go to my set screws folder and save this. And we could take a good look at what a set screw looks like. So this is an example of a set screw here. So this was a 632. So an example of this is, maybe we have a part that's a block, and maybe this block has a shaft that goes through it. Um, let's say this is maybe just 1 inch by 1 inch. I'm gonna extrude boss this to be a 0.25 block. And then maybe in the center, I have some shaft that goes through here. So maybe I have 0.25, and I'm just gonna cut it through. So I'm gonna call this, if I go back to my set screws folder, call this shaft block. Okay, and then typically you'll have some hole here for the set screws. So I go hole wizard, and then you want to do, let's see, it's in inches, and you want tap drills. Could do a number 632. Okay, so I'm gonna position it in the center by adding in a center line. Then I can add my point here and just hit OK. So this is all the way through. But in this case, actually I should be using a bottoming tap here. And then I'm just gonna do up to next. Okay, so this will just be the set screw for our shaft. And for the sake of completion, let's make a quick shaft. Or we can also download one. So find a shaft here. Let's just get a D profile, 1/4 inch. These are, I'll get a cheap one here. Download this. Put in our set screws folder. Open this up. Okay, so this is our shaft, right? And now if I make an assembly from this, let's put our block first, then our shaft, and our set screw. Okay, so this is 0.25. I think I got a shaft a little bit too big. I think I meant to get let's see. Diameter should have been 1/4. Okay, let's try this again. D profile. Okay, let's get this one. Download, save, and we'll open this one up. If I drag this in here, this looks much better. So if I mate this to this hole, you can see this is my shaft to this block. And I'm gonna have this top face parallel. So now you can see that if I mate the set screw to this hole and then I want to flip it. So now if I do the section view, you can see what's going on. Actually, let me do a section view this way. It might be a little bit better. Okay, so you're gonna be inserting the set screw such that the face of it will become tangent. Okay, and depending on how much strength you want, maybe you'll get more threads. If it's something light, then you don't need as many. So in this application, you probably could have gone with a set screw with a longer thread, but at least you could see how the set screw engages with the shaft here. So in our last video, we were talking about the keyed shaft. So like I said, when you do something like this, you may leave a mark where it made contact. And then if you had a nice slip fit hole here, which I didn't add tolerance for this one, but if you did, um, if you try removing this shaft afterwards, you might see some issues because the surface got deformed a little bit. Okay. So that pretty much summarizes what I want to say for set screws. And again, because in this video we showed it with a shaft, you could really just use your imagination what you want to use a set screw for, because as long as you take the concept of a screw going down and compressing something to hold on to it, that's the general concept. And then you can apply that concept to anything else. Maybe you have a cable you're trying to secure, or um, just anything that you're doing. Okay. So if you found this video helpful, give a like and subscribe, and I'll see you in the next one.